Let's start. Okay, and if somebody has any query, any doubt, he or she can directly contact me. And also if somebody is in leave for some reason, then also you won't face any problem, because I am continuously uploading the videos on YouTube. Okay, so even if you miss some lectures, there will be no problem. So in the slide you can see that there are 3 columns. Okay, gender, boys and girls, score, and age group. Okay, and here one arithmetic test has been performed. Okay, one arithmetic test has been performed, and in that particular arithmetic test, okay, you can see that the scores that are scored by different boys and girls belong to the age group of 10 years old, 11 years old, and 12 years old, that are presented. Okay, so yesterday we saw the one-way ANOVA. What is one-way ANOVA? One-way ANOVA means there is one dependent variable and there will be one independent variable. For example, you have seen earlier that I discussed this one-way ANOVA. In one-way ANOVA, you can see that different qualifications were there: vocational, school level, college or degree level, and no qualification at all. So different qualification level we have seen, and we have also seen their income level. Okay, so basically there were one dependent variable and one independent variable. Okay, there was one dependent variable. What was the dependent variable? That was income level. Annual income level was the dependent variable. And what was the independent variable? The independent variable was the qualification. Okay, that was the independent variable. Okay, but in this case you can see that there are 2 independent variables. One is gender and another is age group. So there are 2 independent variables. Okay, and there is one dependent variable. The independent variable is the arithmetic test score. So since there are 2 independent variables, that's why it is termed as two-way ANOVA. If there are 3 independent variables, then it will be termed as three-way ANOVA. If there are 4 independent variables, then it will be termed as four-way ANOVA. Okay, but the dependent variable will be only one. Okay, so the general terminology is that we talk about n-way ANOVA, because it can be, there could be several number of, any number of independent variables you can have, any finite number. Okay, so so now we will see that what will be our hypothesis testing. Okay, so you can see that these are our hypotheses. There are 3 hypotheses. Okay, one hypothesis is, the first is gender will have no significant effect on 3 pair of hypotheses actually. Okay, there will be 3 pair of hypotheses. One is null hypothesis. The gender will have no significant effect on student score, and your alternative hypothesis or research hypothesis will be gender will have significant effect on student score. Then the second null hypothesis will be that age will have no significant effect on student score. Then again, another alternative hypothesis will be age will have significant effect on student score. Then the last pair will be gender and age interaction will have no significant effect on student score. And your alternative hypothesis will be gender and age interaction will have a significant effect on student score. So these three pair of hypotheses will be there when you will be dealing with the two-way ANOVA. Okay. So now how to calculate the two-way ANOVA? Okay. So first we can rearrange this particular table, okay, in these two ways. Okay, we can rearrange these the earlier table, this table, we can rearrange this table in these two ways. One is age wise and another is gender wise. Okay, so first take a look at the age wise. Age wise means you are considering three different columns of three different age groups: 10-year-old, 11-year-old and 12-year-old. Okay, and this is B representing the boys and G representing the girls. Okay, B representing the boys, these are the boys scores and these are the girls. Okay, so now you are going to calculate the averages. Okay, so the average for 10-year-old group, it is 6.5. The average for 11-year-old group, this is 8.5, and the average score for the 12-year-old group, this is 12. Okay, and what is the grand mean? The grand mean will be 9. Okay, so similarly, in case of gender wise, you are taking into account one column for boys and another column you will have for the girls. Okay, this is for 10 years old, this block is for, these two blocks are for 11 years old and these two blocks are for 12 years old. And your the average for the boys, the score is 7.67. The average for the, or the mean for the girls is 10.33, and the grand mean is same, like x double bar is equal to 9. Okay, so now first if you just if you want to compare the two-way ANOVA with one-way ANOVA, then first think that there is you are not considering the boys and girls are not there. Okay, the gender you are not considering. Okay, so how you will do your one-way ANOVA? Okay, so obviously earlier we have seen that you need to find out the total sum of square. Okay, so this will be your total sum of square will be 200. How can you find that? Your grand mean is 9. So in this matrix, each and every element of the matrix you need to subtract from 9 and then you make it square. You add all these things and you will get the total sum of square is equal to 200, which is representing actually the total variance. Okay, now there is you will calculate sum of square between, this is also variance, but this variance is between the groups, between the 10 years old, 11 years old and 12 years old. Okay, so obviously how you will calculate this? If you want to calculate this, it is 6.5, the average, here the group average is 8.5, here the group average is 12. So you, and your grand mean is 9. So you will 6.5 minus 9 whole square. plus 6.5 minus 9 whole square plus 6.5 minus 9 whole square. In this way, 6 times, since you have 6 elements, 6 times you will consider this. Then plus 9 minus 8.5 whole square plus 9 minus 8.5 whole square 6 times. Then again 6 times you will consider 9 minus 12 whole square, 9 minus 12 whole square, like this, because you are considering the sum of square between the groups. Okay, that means how it is the one particular group average, it is differing from the grand mean. Okay, so that you are considering for each element. So that's why the sum square between, it will be, you need to calculate it, and it will come out to be 93. And obviously, since you have 3 columns or 3 age groups, so your degrees of freedom will be 3 minus 1 is equal to 2. And in this case, for total sum of square, your total degrees of freedom will be, it will be 17. Why 17? Because you are having total 6 plus 6 plus 6, 18 elements are there. So 18 minus 1 is equal to 17. So in this case, when you will considering the total matrix, your degrees of freedom will be 17. Okay. So now sum of square within you need to calculate. How you will calculate sum of square within? Sum of square within means the variation between a particular group, between a 10-year-old group, 11 years old group, and 12 years old group. Okay, so in this case, you will subtract from the average. Okay, 4 minus 6.5 whole square plus 6 minus 6.5 whole square plus 8 minus 6.5 whole square, like that. Then plus 6 minus 8.5 whole square plus 6 minus 8.5 whole square plus 9 minus 8.5 whole square, in this way. Then again plus 8 minus 12 whole square, 8 minus 12 whole square, and sorry, 9 minus 12 whole square plus 13 minus 12 whole square. In this way you will calculate, and it will come out to be 107 sum of square within. And what will be the degrees of freedom? In each group you are having 6 elements. So in each group the degrees of freedom will be 6 minus 1 is equal to 5 plus 5 plus 5. So your degrees of freedom will be 15. Now notice that your total sum of square is equal to sum of square between plus sum of square within. That is quite natural. So 93 plus 107, you will get 200, and your total, the degrees of freedom is 17. So if you add these two things, 15 plus 2, you will also get the 17. Okay. So this is the case if you do not consider the gender. So only if you consider the age groups, suppose you have age groups, you are not interested to consider gender, then you can use a simple one-way ANOVA. Okay. And finally, we have seen that in ANOVA you need to calculate the F statistic. Okay, so the F statistic is given by sum of square between minus m minus 1 divided by sum of square within divided by m into m minus 1. Okay, so that this is basically representing, these are the degrees of freedom. Okay, so basically we are comparing this these two variances, sum of square between by sum of square within. These two variances we are considering, but we also take into account the degrees of freedom because it has an effect on the variance. Okay, degrees of freedom has an effect on the variance. Okay, so that's why we are also considering the degrees of freedom. And finally, your F score comes out to be 6.518. Okay, your this score comes out to be 6.518. So similarly, in case of gender wise also, their total sum of square will be 200, just like that, because the elements are same. When you are considering the total matrix, all the elements are same, so it will be sum of square total will be 200, and the degrees of freedom in this case will be also 17. Then you will calculate sum of square between. Suppose in this particular case you are not considering the age wise, if you consider the one way ANOVA. Okay, you are not interested to consider the age, you are only interested to consider the gender. Okay, so in that case your sum of square between will be 32 and degrees of freedom will be 1. Why degrees of freedom will be 1? Because there are two rows, two genders, so 2 minus 1, that will be degrees of freedom will be 1, and sum of square between is 32. Okay, how you have got it? It is the grand mean is 9, so from 9 you minus 7.67 whole square, you do it for 9 times. Okay, then plus 9 minus 10.33 whole square, do it for 9 times because there are 9 elements, so you will ultimately get this 32. Then sum of square within. Okay, if the degrees of freedom is 16, why 16? Because there are 9 elements in a column. Okay, so the degrees of freedom for this column is 9 minus 1 8 plus 8. Okay, 9 minus 1 8, so your degrees of freedom is 16. And your what is your sum of square within score? The sum of square within is 168. Okay, why it is 168? Because the sum of square, how you are getting that? The sum of square within you are getting in this way, that the sum of square within score, the grand mean, it is suppose the 9 the sum of square within means you are considering one particular group. Okay, so you 7.67, this is the average for this group, so you will subtract this from each and every element. 7.67 minus 4 whole square plus 7.67 minus 6 whole square plus 7.67 minus 8 whole square dot dot dot, dot plus 10.33 minus 4 whole square plus 10.33 minus 8 whole square. In this way, all those 8 elements you need to subtract from 10.33 and it will come out to be 168. Okay, so just like that, the F score you need to calculate. You will compare the two variances, sum of square between divided by sum of square within. Okay, so you will get the two variances you are actually comparing. Okay, sum of square between and sum of square within. Okay, so ultimately you will get the score of F score you will be getting is equal to 3.048. Okay, and this score you can compare these two scores from a cutoff value. Okay, so those cutoff value will be depending on the alpha level that you are considering and the degrees of freedom for F. Okay, that is 2,15, and here it will be 1,16. Okay, so in that way you need to compare just like the previous one. Okay, you need to compare with a cutoff value, and you should you should check that whether it is greater or less than the cutoff. Your F statistic value, it is greater or less than the cutoff, or simply if you use software you will not look at the other things, you will directly look at the p value. Okay, if your p value is less than 0.05, then you will reject your null hypothesis. But if it is greater than 0.05, okay, usually, because if usually we take 95% confidence level, then you will you cannot reject your null hypothesis. Okay, so this is the case. Whatever I am saying right now, all these cases are for the one-way ANOVA. Okay, now I would like to tell you that how to do the calculation for the two-way ANOVA. Okay, you can easily understand that for the two-way ANOVA, the sum of square total, it will be